Hello everybody, today I will talk about how to create a mesh file based on SpaceClaim and GMSH software. By the end of this tutorial, you can absolutely create a structure mesh for complicated geometry, something like this. So this tutorial will be divided into four main steps. The first one is to create geometry in SpaceClaim. The second one is export step file (STP). Third one is import this step file into GMSH software and then export the geometry file. The last one is modify the geometry file and generate the MSH file from GMSH. So the first step is to draw the geometry in the SpaceClaim and C software. So I draw the circle represent our cylinder. And then draw a rectangle represent our boundary condition. The important thing here is if you want to create a structure mesh in surface, in subsurface, you need each surface has 8 nodes. So this is the reason why I divide my surface at like this, so that we have each subsurface has 8 nodes. and uh, and etching, and we have a surface here, but right now it's only one surface. We need to divide them into by detect all into a lot of into subsurface like this one, so that in geometry we can easily do naming. And final, I need to check the geometry by check duplicate. No duplicate, good. HRS, no, good. So we save as step file. In the next step, we will import this step file into GMSH software, and then based on this, we export the geometry file which we want. After we have the geometry file, we open this in GMSH and change it first. First thing, we need to change this number CL1 by 1 because it's default number. And then something I will show you right now because it's geometry creator inner SpaceClaim so that the number of line, number of point sometimes is duplicate and we don't want this phenomenon. So that we need to type or click on the software screen like this one, either coherence so that we can prevent and delete the duplicate element. Yeah, you see, we totally delete the duplicate element. Step is finite line and surface. With finite line, we can create in mesh finite line and click on the uh, surface like this one. Choose click on the line you want to, and ending is by type E in the keyboard, U in the undo, and Q in the abort. This one I finished, so I type E. I divide this equally by 10. Do the same thing with another edge of your geometry. Make sure that you choose every line on the geometry like I do with the inner edge. We can mesh it better later, but right now I just divide equally this edge with the progression parameter 1. And then we continue to train finite surface. Right now we can see here that we have around 20 surface. We, we can click on the screen, but right now I prefer to create a loop in the geometry. Don't forget to recombine after we train finite surface. So let's reload the script in meshing. Reload script and mesh 2D. Okay. Oop. We can see here something wrong here. Oh, when I click on the line number 71, I can see that is not have a defined tensile line. So I will adding in the geometry file to line the 71 and 65. Okay, alright. so that we have completely equally meshing. But in reality, in our simulation, we need to mesh fine in the region we want. So the reason we want here is the interaction phase between the cylinder and the internal field, right? So we choose the line we want to have a progression. So I can change the 1.2 here. Oops. Some line have a opposite direction. We want to change the direction of this one. We can see here line number 29 is wrong direction. Line number 7 is the wrong direction. So we adding minus symbol. Similar with the 35. Sorry, 55. Oof. Maybe I forgot to reload script. Okay, let me check again with line 29. Reload the script. Okay. Similar to line number 7. Another line need to fix it. Number 27. Number 51. Number 35. Well, voila, we have a mesh we want. But the mesh we have is a 2D. In Openfoam they require 3D. So we need to go to further step in the extrude this surface. So we can copy paste here to save time. So we can extrude the surface with the layer 1. Number of layer is 1. Yeah, we can extrude the geometry like this one. After we create a 3D model, we will create a physical group for boundary condition. We can choose the surface on the screen and type the name. For example, it's inlet. And remember, press E in the keyboard to finish. Do the similar thing with outlet, top, bottom. Click on the screen, type E to finish. Top and bottom. I'm sorry, it should be front and back. Click on the surface in the on the screen, but please do it as careful as possible. But don't worry, if you make a mistake, you can change it in the script. So it is good thing about this method. Okay, make sure that every surface we want have been chosen. Let's reload this one. So we have inlet, outlet, top, bottom, and top and bottom again. I'm sorry, top and bottom should be front and back. And next thing is the cylinder surface. Again, choose on the screen and press E to finish. Okay, so let's check again. With tools option visibility. So we can show inlet, good, outlet, good, top, good, bottom, good, top and bottom. Of something wrong here. This surface should not be here. This surface 194 should not be here. So we can re-edit in the geometry file. So we can delete 194, delete it. Cool. So we have cylinder, we have boundary condition we want to. We can continue with the volume boundary. We can create by the same method. Click on the screen, type the name. The name of the volume is fluid. Type E in the keyboard to finish. Reload the geometry file. Create a volume for cylinder only by click on the screen. Type E to finish. Type the name. I choose name is mem represents on membrane or something. So in boundary condition we have everything necessary for Openfoam. The final step is exported in mesh file. We can do it by export option. GMSH file. So done. I hope this tutorial will help you to create a structure mesh in your future project. Thank you.